Hello, everyone. My name is Moshe Naveh. I'm an SAP community advocate. Welcome to today's SAP community call about embrace failure, build resilient application with SAP Cloud SDK for JavaScript. Today we have Marika, a SAP Cloud SDK developer. Marika, please take it away.
Thank you very much, Moshe. Also, welcome from my side. And yeah, let's talk about how to build resilient applications with the SAP Cloud SDK for JavaScript. So first of all, I would like to motivate the topic a bit. After that, I will give you a short recap of what the SAP Cloud SDK is for those who might not know it, but also for those who know it, because we have changed a few minor things that you will already see in this part. Then I will talk about resilience and resilience patterns and how to use them in the SAP Cloud SDK. And in the end, I will give you a short glimpse of what are new things and changed things in version 3 of the SAP Cloud SDK for JavaScript. So let's get started. Software is an important part of today's business life. Generally, it touches almost everything that we're doing. And business software is actually very important for businesses. And parts of businesses cannot even be done without software. So if you imagine logistics, for example, software is an essential part of it. But software can only bring value if it is available to carry out its task. If it's not, you have an issue. And yeah, let's talk about availability. So if you try to quantify availability, you will often see this equation or similar equations. And this basically tells you that the availability of a software is its uptime divided by its total lifetime. Or I call it now lifetime being uptime and downtime. So as long as the software exists, it's the ratio of uptime and existence. Obviously, you would like to maximize that, and maximizing that is bringing this value as close as possible to 1. And then in the worst case, you would get it to 0. So if you want to maximize that, what you can do, or what traditionally is being done, is increasing the uptime. With that, we're trying to basically prevent failure. This is a good thing, and we should also continue doing that. But realistically, failures still happen. So it's not always in your hands to avoid failure. So let's talk a bit about failures. Today, I think I would mostly like to concentrate on transient failures, so failures that resolve themselves after some time or only there for a short amount of time. But failures not always are only transient. The most important part that I'm looking at today is transient failures. And examples for this are network latencies, network connectivity errors, overloaded or unresponsive services. And for example, if you do operations like rolling upgrades or moving a service from one node to another, if that turns out to be a temporary failure, those issues are usually self-correcting. As I said, I don't want to limit this whole thing only to transient failures, but transient failures are there very often, and they're usually not a big problem unless you let them become a big problem. So these failures are failures that are usually, as I said, self-correcting, and you don't need a human to intervene to fix that. And these failures also happen a little bit more often than maybe in traditional times now with cloud native applications that might rely on more distributed systems behind that, and there it is even more out of your hands as it was compared to earlier, maybe more traditional, more single process software. Okay, then let's talk about how to maximize availability by decreasing downtime. So this is the more modern approach, and the idea behind this is to basically quickly recover from failure. And once you have a failure, try to get back on track as much as possible. And also, once you have a failure, gracefully, handling this failure so that your software can still bring value and provide the best experience to your users. Now, before we go a bit more into resilience, so this was basically already the essence of resilience. But before we go more into resilience and more of patterns, how to use resilience, I want to recap a bit what the SDK is. So this is the SAP Cloud SDK vision. It says, simplify integration with SAP systems to give developers space to focus on business logic. So integration with SAP systems is key. Let's take a look at a general application architecture with the SAP Cloud SDK. So if you have an application that is running on SAP Business Technology Platform, usually in a productive case, you would also have an app router or something comparable so that users can authenticate and the app router would then forward a job to the application so that you have all relevant information in your application. Next to Business Technology Platform and your application, there are systems that you might want to consume in your application. So most prominently, also historically connected with the SDK a bit, is obviously SAP S/4HANA Cloud. So who knows the SDK historically? We kind of had stronger connections to that, but we opened the Cloud SDK beyond SAP S/4HANA and SAP S/4HANA on-premise, obviously as well, to other services. So basically, any service that is OData, OpenAPI, or theoretically also any other protocol, or as long as it's HTTP based, basically, you can consume with the SAP Cloud SDK. And generally, so you have these systems, you want to consume them in your application, and to do that on Business Technology Platform, what you use is the destination service. If you use on-premise, you obviously also use the connectivity service. For some authentication, or for most authentication methods, you probably integrate with XSUA or something like this. But this is kind of the essence. And here, the SDK comes into play, because with the SDK, it is quite easy for you to retrieve a destination. Later on, we will see a very simplified example that I will use with a local NOC server and so on. But there you will see the same syntax that you would use to retrieve destinations from the destination service as well. And what the SDK does in the background is then calling those APIs from those services or systems. So basically, the SAP Cloud SDK is all about service consumption. So to once more deepen a bit the overview of features that you would have with the SDK. So as I already said, the SDK interacts with the SAP Business Technology Platform services like the destination service, connectivity service, XSUA, and maybe others. And it's in addition to that, we leverage multi-tenancy and caching. So with the SDK, once you retrieve a destination, it is ensured that it's following the multi-tenancy rules. You can enable caching to improve performance. And in addition, now since version 3 of the SAP Cloud SDK for JavaScript, we also have resilience features. There were some resilience features in the past, but now it's even more. One more thing is generator CLIs. So we have CLIs to generate typed clients, and with those typed clients, you can consume services of S/4HANA, SuccessFactors, or Ariba, whatever you need. Also custom services, so services from systems that are not from SAP, but are based on OData or OpenAPI and are connectable through the destination service. You can consume all that with the typed client library. Without explaining it more with text, I would rather show that, because I think then it becomes more clear what a typed client library actually is and how you can use that. So let's take a look at some code. So I prepared a very tiny project here. In this project, I installed some SAP Cloud SDK for JavaScript libraries. So first of all, the generator, and with this generator, or I use this generator to generate my typed client. I downloaded the business partner API specification from the API Business Hub and or SAP API Business Hub, and then generated my client. This is the client. And I basically did not configure much in this client. I only used the naming, so I wanted to have nicer naming for my directory name. So I used these options that allow me to improve the generated results. But generally, I did not use any special parameters here while generating. And this is interesting to those who might already know the SDK, because previously, by default, the SDK would transpile, create a package JSON, and do some more tiny things that are not necessarily the default for everyone. And therefore, we decided to kind of make the default a bit simpler. The default now only uses what you see here. So you have TypeScript code, but you can still transpile and add a package JSON. So all of this is still possible. You just need to configure it then. So now I have my generated code. and let's try to actually retrieve some data. So I have my generated client and I consume the business partner service function here. So I use this business partner service, and the business partner service, you can instantiate that with different kinds of deserialization functionality. I will just use the default, so I don't need to pass anything. And here I have my business partner API. The business partner service has multiple APIs. So next to the business partner API, you will see that there is also stuff around addresses, contacts. There's something about customers, suppliers, and so on. And also some additional advanced SAP Cloud SDK functionality like batch. But today we're not looking at that. Today I really just want to retrieve a list of business partners from my local mock server. So I use the business partner API to create a request. So I call the request builder, and then I call the request builder for get all requests. So this is a request to get all business partners. The business partner API requests have multiple other possibilities. So I could also create a new business partner. I could update an existing business partner, and I could also get one business partner based on its key. But I'm not going to do this today. So let's take a look at get all. And then also what I do is selecting the first name and last name only so that we don't have a bunch of information. I just really want to get the names of my business partners. And ultimately, I execute this request against a destination, and the destination name is S4. As I said before, this is going against, or this will be going in a second, against a local mock server. But theoretically, if you would use this code on Cloud Foundry or even Kubernetes, it doesn't matter. So on SAP BTP, then you would call the business partner server, the destination service, to retrieve the destination with this name. So behavior should be the same, only that I wanted to keep it simple for the sake of the demo. In the end, I execute the function that I implemented here, log the result, and in case I have an error, I log the error. So let's try this and see what happens if I call this. And here we see that I retrieved the business partners. So even the response that I retrieve here is typed. It's an entity type that is provided by the SDK as well. And the properties are first name, last name, and you see that this is a list because we have a get all request. So that's already it. That's how you would generally use the SDK. And now let's get back to topic. So let's talk about resilience and middlewares. In the SAP Cloud SDK for JavaScript, we introduced a new concept of middlewares, and you will need to understand middlewares to understand how resilience works. I mean, in the end, you probably don't need to understand it, but it totally makes sense if you understand it so that you know what you're doing if you're using it. So a middleware in general is a function that is executed before the request to a target system is executed. So in this image below, you can see you basically build the request, and in the end, you would normally execute the request. That's what we just saw. And now you have middleware. So those middlewares are applied on the request, and then it's executed. In the JavaScript SDK, resilience functions are middlewares. And if you're using middlewares, it is important to understand that multiple middlewares are composed. So this looks very mathematical, and I'll just say that basically, if you have multiple middlewares, the first one is wrapped around the second, and so on. So it goes kind of goes down, so that the last one is executed first. You could say so. The order matters, but if this is too complicated, it doesn't matter. We will see it later on in action, actually. So bear with me. So let's maybe implement a small middleware first to understand the concept of middleware better. So I already prepared something. I call it the request logger. This is a middleware. It takes options, and in these options, I have a function. This is basically the other function that is called before so another middleware that is called or the original function before my request logger. So I want to wrap my own function around this. So this is what I'm doing. I have my function and I wrap it around the request, so the original function here. And what I want to do, just to make it simple, I called it request logger. I just log the method of the request that I'm currently working with. So the input parameter here is the request configuration. I log the method and I log the URL. So let's use that. And to use it, there is this new method on the request builders, the middleware, and here I can just pass my request logger. And let's see what happens. Great. So you can see I am logging the request. This didn't happen before. So I added this functionality. Now every request that we send, we can actually see. So I only added the method and URL, not the query parameters, just to not make it too long. Okay, so let's get back here. Then let's start talking about resilience, because now we know everything that we need to know about the SDK and about middlewares and so on to understand how resilience works. So generally, if you research a bit about resilience patterns, you will most likely find those 5. Sometimes you find more, sometimes you find less, but those 5 are the most prominent ones, at least from my research. And in the SAP Cloud SDK, we decided to implement timeout, retry, and circuit breakers. So what you see on the left, but we did not decide to not implement bulkhead and rate limiting, and there are currently no plans to do that. So this is just to kind of set the expectations. We're talking about the left side, not the right side today. And let's start talking about timeouts. So if I go back to my system here and I break my system, so for some reason I have a delay in my system. So all requests in my system are currently delayed by 5 seconds. So let's just see what this looks like. This is my first middleware that is executed. And now I have to wait for 5 seconds. I mean, before it was also almost 5 seconds, but this was probably some kind of transient fault on my local computer. Therefore, let's, I say 5 seconds is too much. I don't want to wait 5 seconds for my request to come back, because if that happens, I know that the system is probably not in a good state, or I know that I can fall back to some other data. I will not fall back to any other data, but I could, right? So let me just add a timeout. And this timeout is a function that I imported from the SAP Cloud SDK resilience package. So I added this here before, and now it was here. And now I imported from this package, and this is how I would call it. So this would already apply a timeout. The default timeout in the SAP Cloud SDK for JavaScript is 10 seconds. And as I just said, 5 seconds is too much for me. So let's maybe do 2 seconds. And let's see what happens. After 2 seconds, we run into a timeout. This is also the error message. And I kind of saved my application from continuing to wait for this timeout. Oh. So as I just said, timeouts are basically a way to avoid requests to get stuck forever or for a long time or a longer time that I want. And basically, to do that, I fail my request after a certain threshold. Usually when you do that, you probably want to find the sweet spot between allowing slow requests to pass, but at the same time, not waiting for too long if your request is going to fail. So this heavily depends on your use case and the application and the context that you're working in, and maybe also the environment. So there are many factors that influence that. So it is very difficult to set a default timeout. We chose 10 seconds as a general timeout, but as you saw, it is quite simple to configure that. You just pass the milliseconds that you want to do. Timeouts seem quite straightforward, and from the concept itself, a timeout is actually not very difficult to understand, I guess. But timeouts can be tricky and timeouts can be dangerous. Therefore, I want to kind of say a word of warning, basically. If you're using timeouts, you have to make sure that you're not executing requests in a manner that causes issues. Because imagine now we were getting data, we were just retrieving data, but imagine I would have created a business partner. How do I know that the business partner in fact was created? Post, so if I create a business partner, I usually send a post request. Post is not idempotent. So sending the same request twice has a different result on the system, because I will not just create one business partner, I will create 2. And in case the request actually goes through in the backend, so it actually works, but I timeout earlier, or sometimes you can also send timeouts from the backend and still the operation goes on, you can run into problems. So there are solutions to that. I will not talk about the solutions today, but just a word of caution, basically. Timeouts seem very straightforward and easy, but they can be very dangerous if used wrong. Okay, so let me reset my system. System is healthy again. And now what I want to do, so we talked about transient failures before, and I want to simulate a transient problem. So some network issue, my request just fails because of some reason that I don't understand. Maybe it's out of my hand. So the next 2 requests will now fail. I broke my system in a way that it's currently flaky and will fail for 2 requests. So let's just quickly see what happens if I do that. Yeah, the request fails, so it comes back immediately, but it failed. And I can try again, and it still fails. And the 3rd time I do it, it is okay again. Now, these kinds of cases, so maybe you might be able to avoid these issues, so that you don't want the user, maybe in this case, to reload the application to make sure that it works. But maybe you can just do it in the background because it's an issue that is known, or an issue that that can happen from time to time. So you can basically make your application gracefully degrade that basically somehow by calling it retry. Retry is again a function that is imported from the resilience package. And yeah, that's already it. I mean, this will now call 3 retries or implement 3 retries. So the default value is 3. You can obviously also change that or change it to another number. Let's keep it at 3 and just try that again. So, oh, I did not break the system anymore. So let's make it flaky again and now try it again. So in total, the retry will execute up to 4 requests, because you have the original request and then you have the 3 retries, right? So by default, it will be up to 4 requests. So you need to know that that you're doing that as well. So we can see that that now it worked. So my logger also shows that I executed the request 3 times, and my results is back again. So yeah, cool, that worked. So let's talk a bit more about retries, because retries are actually quite interesting. A retry is basically with a retry we try to repeat failed operations that we think are likely to succeed. So if we think that a system failure or a failure is not transient, we should not retry. So therefore, we should only retry if a failure seems transient. With the default implementation of the SAP Cloud SDK, we believe that that HTTP errors with status code 400 something are usually not transient, because if you imagine bad request, for example, will mean that your request is wrong somehow. Authentication issues are usually, a problem with authentication. So repeating it probably will not bring a different result, and therefore those are not repeated. So if you're using the default implementation of the SAP Cloud SDK retry, you will not retry HTTP errors with status code 400 something. By default, as I said, we're using 3 retries, and you should also retry with a delay. So if you have a problem or if there is some kind of fault, in most cases, it doesn't make sense to just retry. Instead, you put a delay in place to ensure that potentially if the system is under a bit too much load, maybe you give the system a bit time to recover from the load. And therefore, you have a delay between those retries. And in the SAP Cloud SDK case, the delay actually grows exponentially. Under the hood, we're using the async retry library, which does that for us, basically. But what happens if you have retried multiple times, but it's still failing? Then you should probably retry immediately, because then it seems like it's probably not a transient failure anymore. And before I show how to solve that, let's maybe first look at the slide. So in those cases, you would probably use a circuit breaker. I would say the circuit breaker is kind of the opposite of a retry, because in a retry, we said that that we expect that the system will succeed. So we try to repeat the operation. Here we do the opposite. We expect that the operation will fail, and therefore we try to prevent the operation. In that sense, a circuit breaker acts as a proxy. So it decides whether a request goes through or not. And it does that based on statistics that it collects. And based on those statistics, it then goes into 3 different states. So let's talk about those states. The standard case, the default case or default state is closed. So we assume the system is healthy, and same as with power, basically the power flows through the closed circuit breaker. So everything is intact, everything is working, everything can flow, and all operations are led through. In case the circuit breaker encounters a problem, and in a short amount of time, there are many requests or many operations that fail, the circuit breaker will actually go into state 2, which is state open. And that means there's probably some kind of system failure, and all operations will fail from here on. Obviously, this should not be there forever, so you don't want to remain in state open forever. Therefore, after a certain amount of time, in the SAP Cloud SDK default case, it is around 30 seconds. After around about 30 seconds, the circuit breaker will enter the state half open and will let some operations through. So it will be very cautiously trying to check whether the system is okay, because it expects that the system might potentially be recovering. If the requests pass, then it goes back to state 1 and enters the state closed. But if the requests do not, or the operations, I always talk about requests, but the circuit breaker concept is not necessarily based on requests. It's generally about operations. If you look at the operation and it fails, then it will go back to the open state. And from this state, again, it will give the system a bit time to recover and try again with the half open state. So obviously, if you have a circuit breaker and it is open, there should be no retries, and the default implementation of the SAP Cloud SDK also takes care of that. So let's try to use a circuit breaker. So first of all, I have to switch to a bit more complex demo setup because the circuit breaker requires that. So show that. So generally, I do the same thing. I try to execute my get business partner request, so getting all business partners, and I log the results. And if that is successful, I'm done and everything's cool. If not, I log the error and try again. So that's why I have this while loop around here. And every 100 milliseconds, I try to make a request. Let's try to break the system, and then I will say a few more words about breaking the system. So now I broke the system, and for 10 seconds, every request will fail. And every request that I send towards the system will actually add a 1-second penalty to my broken system. The idea is here to basically simulate that you have a system that is broken due to high load. And if you're trying to push the system more, it will actually go into a more broken state, basically. And if the penalty reaches 30 seconds, then for me, it's basically like, this is beyond repair, and we're not fixing that anymore. So we stop, because otherwise it would run endlessly. I think I made a mistake. Maybe I talked too long. Just make sure that I am not forgetting something. No, actually, it looks good. So I'm not doing anything, and I just repeat it all the time. So probably I just talked too much. Okay, so now we're sending requests, and one after the other. And you can see that I sent 27 requests. So probably after 3 seconds this time, not after 10. I started this, and yeah, we raised the penalty to 30 seconds so that I stopped the logging here. So yeah, that doesn't make sense. We shouldn't do that, right? So that's exactly the case for a circuit breaker. So let's use the circuit breaker. We do the same thing as before. We have the middleware and import the circuit breaker. Again, from our resilience package here. And yeah, that's it. Let's try the same thing again. So it's sending requests, but after 10 requests within a short amount of time, it says, oh no, the system is broken. I shouldn't send more requests. And as I said before, this will take around 30 seconds for the circuit breaker to go into the half open state and then check, maybe send one request and check if the system is okay. As the original time here was 10 seconds, we added 10 seconds by calling it constantly. It should be healthy after about 20 seconds. So 30 seconds is exactly right for this system to recover. And as you can see, it recovers in the end. In the case before, we just broke the system. So this is kind of the case for a circuit breaker. And I hope that it became clear that it's quite straightforward to use the circuit breaker. One more thing that I wanted to show with regards to resilience is the default resilience configuration that you can use. So there is also a resilience function in the SAP Cloud SDK. You also import it from the resilience package and pass it to the middleware function here. And it works the same way as the other resilience functions. So it's basically a list of middlewares. So it includes 2 or 3 middlewares. By default, actually, we turned off the retry. So we decided that retries can be dangerous. And if you want to use a retry, you should really absolutely be sure that you want to use a retry. And if you want to do that, you can just enable it by setting retry true. Or if you wish, also configuring it to a number that you like. You can do the same with the timeout. So as we've seen before, if you want to have a timeout of 2 seconds, that's how you can configure it. And if you say you want to use the resilience function, but you don't need a circuit breaker, you could also disable the circuit breaker, for example. So that's just an example of the things that you can do. I know that many users of the SAP Cloud SDK actually use the generic HTTP client. So this is a typed client for a specific service, and you can generate as many of those as you like, and then send multiple requests through different APIs. But there's also a generic HTTP client from the SAP Cloud SDK that integrates with the destination service, similar to this. And there you can also configure middlewares the same way as you have seen here. I mean, not exactly the same way, but conceptually, it's exactly the same thing. Okay, so let's take a short overview over resilience in the past and the future, or in the past and now, basically. Because if, in case you used resilience in the past, you might be aware of some features, but maybe, I just wanted to compare that a bit to make clear what is available, what was available, and what has changed. So the timeout was available in version 2 already, and it was enabled by default for SAP BTP services as well as for target systems. We changed this in version 3, so it is available for both target systems and BTP services, and we enable it by default for BTP services, but we do not enable it for target systems. So you saw how to enable it for target systems yourselves, and this is kind of the new concept to do that. Then retries were not available in the old version. It's now available for both SAP BTP services and target systems, but it is not enabled by default. So for target systems, we saw how to do that. For BTP services, we did not see this, but I will also not show this today. So refer to the documentation if you're interested in that. And the last thing is a circuit breaker. So in the past, you were able to enable circuit breakers for BTP services. They were not there by default. So they were available, but not enabled. Now they're enabled by default, and you can also not turn them off. But for target systems, they are available, but not enabled by default. So all those things, as you saw, you have to do on your own. So you need to know what you're doing and decide explicitly to do that. So the last thing that I wanted to talk about, what else is new in version 3? So we saw the middlewares and the resilience, which is basically the heart of version 3, I would say. So the biggest new feature, but we also have some other things. For example, sending emails through the SDK. So there are on SAP BTP, next to destinations of type HTTP, you also have destinations of type mail. And with the SAP Cloud SDK for JavaScript, since version 3, it is officially possible to send emails using those destinations. This was already available in version 2, but there it was not, it was still beta basically. We also aligned the generator APIs between the OData and OpenAPI generators. So you already saw a short glimpse of that. I did not use the generator, but I showed you that I used it before and explained a few things. So defaults have changed. We simplified many things and aligned them. So in case you're using both OData and OpenAPI, you have a more similar experience. Then we removed a lot of deprecated functionality. So over time, things accumulate usually, and to clean the API, to make it more clear for everyone, we removed those deprecated functionalities. So there you will probably find some changes that you need to adjust. But also we discontinued the pre-generated clients. So in the past, we had we have the generators, and we used the generators ourselves to generate clients and then publish them to NPM. We discontinued that because we talked to a few users and realized that there are different use cases where sometimes it doesn't even make sense to use the pre-generated one, and people would generate the same ones on their own. So we just decided to not put in the effort for this, but concentrate on other things instead. And therefore we improved the generators so that the experience here is even better. And the last point here is that the minimal version supported by the SAP Cloud SDK, starting with version 3, is going to be Node.js 18, because Node.js, so smaller versions of Node.js are going to be to reach their end of life within this year, and we decided to therefore already switch to Node 18. The default in Cloud Foundry currently is also Node 18, so this should not hurt too much, I hope. And with that, I say thank you very much for listening. Here you have some resources, community pages, and so on. The Cloud SDK documentation portal, if you're interested in Java as well, maybe there's also Java content on there, and our GitHub for the SAP Cloud SDK for JavaScript.
Thank you very much, Marika. We had one question, which is how can we implement fallback in case of timeout?
So there are different ways to implement that. Maybe I'll just go back to the code. So theoretically, if I look at this code, maybe this is already the fallback, right? It will fail. You can see in the error, you will be able to see that it's a timeout, and you basically just implement your fallback. That would be the easiest, straightforward way. Another way is to add, potentially, that kind of depends on what you're trying to do, to implement another middleware. So if you realize that you have a timeout, so you have the middlewares and you have a timeout, and you have your own my middleware where you do something with the timeout potentially, and you get different data, you get maybe get data from a different resource or something like that, then you can replace the data in here and let the downstream parts of the business of the SDK deserialize your data, for example, right? So you could leverage that through a middleware as well. So there are different ways. It heavily depends on the case.
Great, thank you very much. If anyone else has questions, please post it in the chat. Let's give people a minute to do so. And if not, we'll close the call. So let's see if people add something. Okay, so I guess we're good. Thank you everyone for joining today. The recording will be available in the SAP community channel. Thanks a lot, Marika. And I wish you all a great day.
Bye-bye.